All right. So we're going to talk about section 2.3 today, which is talking a little bit about vertical um, stretching and shrinking or compressing. So again, we're just talking about transformations of graphs, a lot like what we talked about in 2.2. But I wanted to just do a quick review over 2.2 and just to see, just to kind of talk you through this a little bit again. So if we're given, remember, you do need to know the parent function. So be sure you know the parent functions and recognize that this is a quadratic, this is an absolute value, and this is a square root. You need to be able to recognize those. So here, this is saying the function, which is the quadratic, plus or minus c. So what I would ask you is, given this graph, can you write what this function is? So we're going to say, all right, so this is, with the translation. So y equals, so this graph is a parabola, right? A quadratic function, which is x squared. So that's going to be an x squared. Now, what kind of translation do I have here? What did I do? Because it starts at 0, 0. And I just moved it up 1, right? So that's going to be plus 1. And that's all it is. Now let's look over here at this one. All right, so this one, do you see we have a horizontal translation? And how many? It looks like 1, 2, 3 to the left. So when we write this one, now this is an absolute value, so I'm going to put an absolute value of x. And because I have a horizontal translation, I'm going to put that within the absolute value bars. So this is 1, 2, 3 to the left. So remember, when we write a horizontal, we're writing it as the opposite sign because it's the formula is minus, right? So if I put a -3 in there, it's minus a -3, which makes it a +3. So it's always the opposite sign of the direction that we go. And there's a horizontal. So here's a vertical translation, horizontal translation. All right, what about this one? So recognize, first of all, and I might ask you, name the parent function. So you would say square root. And then you would write whatever that translation is. So y equals, we know it's the square root, so we're going to put a square root here of x. Okay, do I have a vertical translation? If this always starts at 0, 0, did I translate it this way? I did, to here, and then I went to here, right? So I translated it over here. How many units is that? 1, 2, 3 to the right. So how do I write that? This is just like the parentheses or the bars. If I want to put 3 to the right, it's going to be a -3. Horizontal translation, 3 to the right, and then we went down 2. So at the end, outside, not underneath the square root, we do a vertical translation of down 2. And that's all it is. That's all it is. All right, so maybe you want to practice some of those out of your book if you need to. So now we're going to talk about 2.3, and that's just going to be vertical stretching and compressing or shrinking, vertical and horizontal both. So I was trying to see here where I have my, oh, here they are. Okay, so let's take a look at this first of all. So when I talk about a vertical stretch, so I just want you to look, and you might want to take these notes down. You can pause this and write them down if you want to. Try and get it as clear as I can. So this is saying C is your constant. So when we see a number outside of the function, okay, and this number is greater than 1, so all that means is it's not going to be a fraction. And we don't worry about the negative. The negative, like if I had a -2 outside of here, the negative is a reflection, and we're going to talk about that next. So we don't worry about the negative. We just look at the number. So if it's greater than 1, so that means it's not going to be a fraction or decimal. We never put decimals in here anyway. Then what we're going to do is, that means we multiply the y values from our parent function by whatever this number is. All right. So our normal point, so if I pick off our parent function, say we have a parent function of absolute value. Let me go ahead and just write that down here. So let's say I have a parent function is the easiest one to look at the numbers, the ordered pairs on it. So let me go ahead and just do that one. All right, so there is a parent function. So notice I just look at these points. So we have point 0, 0, and here's point 1, 1, and we have point 2, 2, and so forth. So this point, it's a reflection over here, right? So that's a -1, 1. We talked about reflections. Axis of symmetry, but that's not what I'm talking about now necessarily. So -2, +2, and so forth. All right, so that's just the parent function. So what this is saying for your vertical is that we're going to take whatever number falls in front of our function, as long as it's greater than 1, and we're going to multiply those y values by that. So let's say, since we have absolute value, let's say that we have y equals, here's the parent function, right? That's parent function. So let's put a number greater than 1. So let's say we have, outside of here, 2x. So what that is saying is you're going to take these y values and we're going to multiply the y values by 2. So this 1, 1, I'm just going to kind of show. So if I have 0, 0, this point, it stays 0, 0, because if I multiplied this times 2, it stays the same. So maybe I should show you up here. We're taking this, and it's going to become this. We're taking, because this is a 2. If this were a 3, that would be a 3, whatever that is. So we're taking our y values times that number. So this point would be 1, and then 1 times 2. So it's going to become 1, this point right here now. Okay, and then this point would be 2, and if I take the y value times 2, it's going to be 4. So that's going to be over 2 and up 4. So that's where the new point is. Well, these are just reflected over. Or I could do the same thing. Negative 1, 2, negative 2, 4, same thing. And so this is, so do you see that that is stretching? This one is called a vertical stretch. And when it stretches, in this case, on a vertical stretch, the stretch means it's getting closer to the y-axis. And you can see that, right? It's getting closer to the y-axis. So if this were a 5, it's going to get even closer to the y-axis. And so it's stretching it vertically. All right, remember, and how I remember that I multiply the y is because vertical is y. So that's how I know I work with the y on this. So let's, and I guess I'll go ahead and just show you this one before. I'm going to show you a little bit on Desmos as well. But let's look at a vertical shrink. So if we have a vertical shrink, it's going to be kind of the same thing. So here's a vertical shrink. The only difference, okay, so if it's a shrink, that means that your constant's going to be a fraction. Okay, again, don't worry about any negatives. We're not going to worry about the negatives. This is going to be a fraction. Whereas up here, it's a whole number. So if it's a whole number, it gets closer and closer and closer to the y-axis. Well, here, if it's a fraction, I'm still multiplying. It's still vertical, so I'm still multiplying it times y. It's just now I'm multiplying it times a fraction. So if I have this point right here, let's say if I do, let's say I take, make sure you can see this here. I take y equals, let's just do 1/2. So instead of this being a whole number, it's half, but I still do the same thing. So I'm going to multiply it times the y value. So these are my parent ones. Okay, so here's the parent right here. So if I have 0, 0, if I multiply the y value by this, it's still 0, 0. Okay, if I have 1, 1, if I have 1, 1, and I multiply a y value by 1/2, that becomes 1, 1/2, right? If I have 2, 2, and I multiply the y value by 1/2, well, what's 1/2 of 2? It's 1. So let's see what that graph would look like up here. I'll use I got a pencil here. Pencil that works. Here we go. All right, so let's see what that will do here. So we're at 0, 0, and then 1, 1/2. So let's go over 1 and then up 1/2. And then we're going to go over 2 and up 1. And then I can just do a reflection if I want to go this way. All right, so here then is that graph. Well, what axis is that getting closer to? This is getting closer and closer and closer to the x-axis. So that is a vertical shrink. All right, that's a vertical shrink. So looking at the notes here, sorry if you hear my dog barking outside in the background. It's kind of a pain today. All right, so here, when I multiply it times its fraction, it's going to get closer. It's going to widen, and that's also called a compression. So it can be a vertical shrink or a compression. You'll see it both ways. So they mean the same thing. Okay, so shrink and a compression means it's getting closer to the x-axis. And a stretch means it's stretching up and it's getting closer to the Y. So let's just take a couple, and I kind of showed you by graphing that, but I just want to show you a little bit on, let's use Desmos so you can get a better picture of it than just my sketch. Oop. All right, so let's take a look at just the absolute value. This is the Desmos again. So let's just do, actually I don't think I even have to put Y equals, I think I can just put absolute value. Let's see. So to find the absolute value here, I believe we have to go to functions. Let's see if we can find it. Might be under, let me find it. I guess I should have done this ahead of time. I thought I knew where it was. Okay. Let's see. For some reason, I can't remember where the absolute value is. I'm not sure. It's got to be in here. Wow. Well, I thought it was in here. Am I missing it somewhere? Okay, well, because I can't find it, I know it's in here and I'll find it for you. I'm not sure why I'm struggling with that. I use it all the time. Anyway, so you know what? Instead, let's just do a square root. So let's do square root of x. So we see just kind of what the parent function is. All right, so if I want to do a vertical shrink, that means, I'm sorry, vertical stretch, that means I'm going to have something like, let's do 2 square root of x. Okay, so you see how if this number is greater than 1, it's getting closer, stretching up closer and closer and closer. So let's see if I have 5. Oh, let's do 5. And look how close it's just getting closer to the Y. So that's a vertical stretch. And it's because it's vertical, we're multiplying these original points, all of these ordered pairs, the Y values we're multiplying times whatever this number is. And when you do that, it gets closer and closer to the Y. So that's a stretch. So I would expect you to be able to look at that graph, and if I have something like 5 squared of x, you would be able to tell me that it has a stretch of 5 units. Okay, I want you to be able to say that. And so let's go ahead and look at, okay, but what happens, I'm going to leave a couple of those on here. What happens if I do now a fraction? All right, so this is going to be a vertical shrink or a compression. So let's say we have 1/2 square root of x. Oh, let me try that again. So on this, you got to remember that you have to arrow to the right to get that. There we go. So then square root of x. So look how that now is getting closer to the x-axis. So let's try another one. Let's try a smaller fraction. How about something like 1/8? Let's see what that looks like. So 1/8. So that black line. So you see how it's getting, they continue. And so that's a shrink. And that just means it's shrinking down. It's compressing down. Either word, be sure you know that both of them, because you'll see both words up there. So, all right, so there's a good example of being able to see that. So the next one I want you to look at is, I want you to take a look at these. So now we talked, those were the vertical. Now let's take a look at the horizontal. So the horizontal is, so what do you think I'm talking about with horizontal, X or Y values? Well, horizontal is going to be right or left. So that's our X value. So now we're talking about our X values. So when we want to do a horizontal stretch, now when we do vertical stretching, we multiply the Y values. When we do a horizontal stretch or shrink, sorry, I got to get these over here. Either one, if we do a stretch or a shrink in the horizontal, we're going to divide by the X value. Okay, instead of multiplying, we divide. And instead of it being the Y value like it is in the vertical, it's the X value because it's horizontal. So when we do a horizontal stretching, so here's a horizontal stretch. And I'm just going to stick with the absolute value because it's just easy to use these ordered pairs, all right? So these are the original ordered pairs on the parent function. So I'm just going to rewrite those down. And I could put as many as I want. I'm just going to go with those three. So a horizontal stretch is saying that we're going to take our ordered pair, and we are going to divide the x value by whatever that constant is. So up here, we multiplied the y value because it was vertical. Now we're horizontal, so we're dealing with the x value. And when you do horizontal stretch and shrinks, you divide the x value. All right, so if we have something like this, again, let's just do an absolute value. So what this is going to look like now is we're going to have the absolute value, and that constant's going to be underneath here. So we're going to have something maybe like a 2x. Right? If it's outside here, it's a stretch. If it's inside, this is going to be vertical, excuse me. It's going to be a vertical stretch or shrink, but it's vertical. Inside here, it's horizontal. So notice when I write it here, it's on the outside. That means vertical. On the inside is horizontal. So if I want to do a horizontal here, I'm going to divide all of my x values by whatever this is. So 0 divided by 2 would be 0. Okay, so what is 1 divided by 2? Well, that's 1/2. And then what is 2 divided by 2? Well, that's 1. Okay, so I need to change this to, I'm going to change this to a 1/2. Okay, this needs to be a fraction. So I'm sorry, I need to change it. I'm going to rewrite it. Y equals square root of, okay, because we're going to do absolute value. I think maybe I've had enough talking here. All right, so here we are. All right, so let me just change these up a little bit because we're talking about a horizontal stretch. I kind of messed you up on that, I'm sorry. A horizontal stretch means that your C has to be between 0 and 1. All right, so if it's a stretch, it's between 0 and 1. So if I have a stretch here, that means, again, I'm going to divide the x values. So this would still be 0, 0. Okay, if I have 1, 1, I'm going to divide the x value by this. So what is 1? What is 1 divided by 1/2? It might be easier to see it like this, 1 divided by 1/2. So that's when we end up multiplying times the reciprocal, right? When we divide by a fraction. So how we solve that is we multiply by the reciprocal. So that would be 2 over 1. So it's 1 times 2 over 1, which is 2. 1 times 2. So this would be 2, 1. So if we have 2, 2, it's saying, all right, let's take our x and divide it by 1/2. So we're going to take 2 divided by 1/2. Well, that becomes 2 times 2 over 1, which is 4. So this would be 4, 2. So let's see what that graph looks like. All right, I'm just going to do it on Desmos because it looks a little bit better on Desmos. So let me share that again. Let me find my Desmos here. All right, so we're going to start with just, let's go ahead and do the square root again. So let's do square root of x. All right, so what happens if, and I'm using a fraction, and it's going to be inside the square root. So let's do 1/2. And this is going to be a horizontal stretch. So let's see what happens. All right, so our original is red. So what's happening on this horizontal stretch? It's getting closer to the x-axis. So if I want to do another one, maybe try 1/4. Okay, but put it in correctly. Again, it's getting closer. So a horizontal stretch gets closer to the x-axis. All right. And then our last one is a horizontal shrink. So same thing. The only difference here, this is when I was writing originally, this number constant is greater than 1. So again, you divide your x value by whatever it is. So it doesn't matter if you're stretching or shrinking, you always divide your x value by whether it's a whole number or a fraction. And then that's going to get closer to the y. So let's just take a look at that. So if I now, inside here, I have a, let's say 2. I have a whole number greater than 1. So you see here, red is the original parent function. We're going to get closer and closer and closer. Let's do something like square root of 10x. Let's see what that looks like. Yeah, it just gets closer and closer and closer. And that's a horizontal shrink. So hopefully, I think what would be good for you to do is to be able to just pause this video and be sure that you have these notes. So pause it there so you can write them down, because I think these are really good references for you, but you do have to know what they are. All right, so let me move on here with a couple things. All right, so let's talk a little bit about a reflection. All right, so let's talk about a reflection. So reflections, all they are is when we put the negative signs out in front. So if I have something, I think it's easier if I turn my camera so it's not so crooked to you here. There we go. So for reflections, if I have, so let's just say I have whatever the function is. It's absolute value, quadratic, whatever it is, that's my function. Okay, if I have a negative on the outside of that function, okay, then what that means is there's a reflection across the x-axis. So whatever point I have on my graph, because it goes across the reflection across the x-axis, then that means it's going to change the y, right? If it's around the x-axis, that means it is going to change the y value. So it would be this. Okay. And so if so I'm going to come back to that. We're going to talk about that in just a minute. I just want to be sure you get these written down first. So if I have the function and it's inside the parenthesis, that is a reflection across the y-axis. Okay, like hot dog, hamburger. Isn't that what you used to say? Anyway, all right, so here is AB. If we have a reflection across the y-axis, then that changes the x. So it would be a negative, changes the sign of the x. So I might ask you something like this. Let's do this. This is a coordinate graphing. Okay, so this is kind of a coordinate. So let's say I have, let's see, this point and this point, this one, and this one. Let's go here. All right, so let's say I just have this, oh, dang it, and I'm using a pen. All right, so let's say I'm doing that function right here. A little problem getting to the point right here. So what is this point? Well, this is point negative 2, 1. This is point, let's see, 1, negative 1. This is point 2, 1. And this is point 1, 2, 3, 4, 2. All right, so those are the original. So that would be a parent function of that function, the original, okay? It's just that we don't use that very often. This is just coordinate graph, so we don't use it very often. So the question then, let's say, well, what if I wanted to, what would that graph be if I had, what would that graph be if I had this function right here? So I'm saying this is f of x. That's what this is. So what would this be? What would it look like? Well, this means it's a reflection over the x. So here's the x. So these are all going to reflect over the x-axis, and that's what the new graph would look like. Now, sometimes maybe you can't see, maybe it's hard for you to see that. So all I do is I take these original ordered pairs, and if it's a reflection over the x, I change the y value. I change the sign of the y value. So that then would become, I leave the x, the y value becomes a negative 1. I just changed the sign of the y values. So this would be 1, positive 1. This would be 2, negative 1. And this would be 4, negative 2. And then I could just plot those points, and that would show that reflection. All right. But I could also just look at it and go, okay, well, here's the reflection over the x. Well, that's negative 2, negative 1. And this would reflect over right here, which would be 1, 1, right? Well, I know that now. I mean, I wrote that down. And then this would go here, which would be 2, negative 1. And then this would go here. So those are all reflection over this line. So this then is what my new graph would look like as a reflection over the y-axis. I'm sorry, a reflection over the x-axis. So what if I said, okay, well, show me then what would this be? Well, that's going to be a reflection over the y-axis. If it's inside, it's over the y. So that means I would change, go back to my parent functions, and I would change the sign. What am I doing? Reflection over the across the x over the y. So I'm going to change the sign of the y values. So this becomes of the x values. I'm sorry I'm saying that. I'm sorry I'm saying that wrong. So this is a reflection over the y-axis. So I'm going to change the sign of the x value. I just had to slow down and say that correctly. So change the sign. Okay, so this becomes a negative 2, 1, and this becomes a negative 4, 2. There we go. Now I could probably look at this and go, all right, well, I'm going to take this point and I'm going to reflect over the y, and it's going to go right here. I'm going to take, and so what that changed to, right, was 2, 1. I'm going to take this point, I'm going to go over the y-axis, and it becomes right here. Well, that's what this point is, negative 1, negative 1. I'm going to take this point, and I'm going to go over the y-axis, which will become right here. And then I'm going to take this point and go over the y-axis, which will go clear over here. All right, so my graph is just getting kind of sloppy, but this would go here, up to here, and over to there. And that would be the reflection over the y. All right. So let me ask you this. This is what I really want you to be able to tell me. So let's say I gave you this. Okay, and I asked you to tell me what is the transformation? Explain the transformation of this graph. So, you know, I kind of want you to try and stick to this order. You know, it doesn't always, it's not always important, but I do want you to get used to the habit of kind of talking about it in this order. I'm not going to mark it wrong if you don't, but I want you to try, okay? Because it can change things if you don't have it in the correct order sometimes. So I want you to start here. So let's start with that. So this is going to be number 1. So what do we do for number 1? So this, first of all, what is the parent function? So tell me the parent function. I know it's whatever this part is right here. So it's an x squared. So it's going to be a quadratic. So tell me the parent function. So it's a quadratic. Okay, now what kind of shift is this inside the parentheses? Well, that's going to be a horizontal shift 4 to the right. Horizontal shift 4 to the right. Right? It's opposite direction inside the parentheses. It's quadratic, horizontal shift 4 to the right. Okay, now don't look at the negative. Look at the 3. What does that 3 tell us? First of all, since it's out here, it's a vertical shift. And because it's a 3, is that going to be a stretch or is that going to be a shrink or compression? And you can use either word. So this is going to be, what I would say on this is this going to be a stretch by a factor of 3. All right, that's going to make it closer to the y, right? It's going to stretch. All right, so that's the second part I want you to do. Now let's talk about this. Let's talk about the reflection. So remember, it can either be here or there could be one inside here. If it's on the outside, that's a reflection across the x-axis. So it's going to be reflected across the x-axis. And then I probably should be marking here. So we did this second, we did this third, and then lastly, we'll do this. And so what is the last one? Positive 5, that's a vertical shift 5 units up. Okay. So that's pretty much what I want you to kind of tell me. So let's do another one of those. So let's do one more of these. All right, so let's try this. Y equals okay, let's take a look at that. So let's start here with our horizontal. So that's a horizontal. I'm just going to say an HS, horizontal shift, 2 to the left. Okay, what's the parent function? It's quadratic because this is an x squared. Okay, so the next thing we're going to do is this. So again, it's vertical. So what kind of, is that going to be a stretch or is it going to be a shrink? Well, it's going to be a shrink or a compression. So it's going to compress or shrink, either one, by a factor of 1/2. Okay. So what does this tell us right here? This is a reflection over the y. Out here is the x, inside reflection across the y-axis. And then down right here, we have a vertical shift down 1. Vertical shift down 1. I want to do one more. So I'm going to squeeze it in over here. Actually, I can turn it over. All right, so let's do this one. Let's do a y equals okay, that's not the one I want to do. I want to do this one. All right, so let's take a look at this. So let's start in here on our vertical. Do I have a vertical shift there? Or horizontal shift, excuse me. Do I have a horizontal shift here? I do not, because I don't have a number, a plus or minus. I don't have an operation in there. So I do not have as far as a plus or minus. So there is not a horizontal shift. So don't worry about that. So the next part I'm going to do is I'm going to go ahead and come out here and right here, we're going to go ahead and go with, what is this going to be? That is going to be, so is that going to be a horizontal? Okay, so we know it's inside. So that means it deals with the X value. It's going to be horizontal. And is that going to be a shrink or a stretch? What do you think? A shrink or a stretch? Okay, that's going to be a horizontal stretch. So that's going to be, let's do a horizontal stretch with a factor of 1/2. Okay. And then what does this do? That's a reflection over which axis? Out here. Which one is that? It's going to be across over the x-axis. You know, I feel like I need to listen to you guys answer. I kind of pause for you to answer. I guess I'm not going to hear you. So, and then what do we have here? We have a shift of what? Vertical shift up 1. All right, so you can practice some of these in your book if you want to do that. All right, that's kind of the things I might ask you on a test. So, you know, explain how this would shift, type of thing. And also, what is the parent function of this one? I didn't ask you the parent function. Parent function here, absolute value. Because these are absolute value. Same. Okay. All right, you guys. I think I'm done for the night. Have a good one.